Seal integrity is critical in the packaging industry. The ability to securely seal products improves quality, freshness, safety, and provides tamper evidence. Welding a liner to a package is one of the most common methods of creating a seal. And in order to achieve a good weld performance, we need a combination of time, pressure, heat. There are two main welding processes widely used in the packaging industry. The first is conduction welding. Simply put, conduction welding is achieved by the contact of a hot device to the liner and pressuring it against the sealing surface of the container. Here's how it works. First, a resistant element heats the conduction plate. The liner is roll-fed and placed on the top of the container. The conduction plate is pressed against the liner using a particular pressure for a certain period of time. The plate transfers the heat to the liner, melting the polymer layer and sealing the package. The liner is cut into the final shape. The overcap is applied. Some of the advantages of conduction welding include: it can be used with metallic or non-metallic liner material, and it can be used for round or non-round shapes. Some disadvantages of conduction welding include: energy intensive, requires a longer startup and setup time, requires a higher top load, more dangerous for the operator due to the high temperature of the conduction plate, longer cycle time, and the overcap always needs to be post-applied. The second alternative is induction welding. Unlike conduction welding, induction welding uses an electromagnetic field to induce heat to a metallic liner or foil. Here's how it works. A generator sends an electric current through a coil. The electric current travels through the coil and charges the capacitor. Once the capacitor is charged, it sends the electric current in the opposite direction, creating an alternating current in the coil. The process is repeated in high frequency, back and forth for a certain period of time, creating an electromagnetic field around the coil. The electromagnetic field induces an electric current on the foil, creating heat. The heat melts the polymer layer on the foil, welding it to the part. Typically, on a conventional induction welding process, the foil is already placed inside the closure, which is applied before going through the induction process. Like conduction welding, conventional induction also requires pressure on the foil to create a good seal. This pressure is created by the torque from the threaded closure applied to the container. Notice that the foil is only welded to the container, not the closure. Some of the advantages of conventional induction welding include: consumes less energy than conduction, faster than conduction, adaptable to various neck diameters, hygienic due to non-contact nature of the process, overcap and foil can be applied at the same time, safer as there are no heated elements on the equipment. Some of the disadvantages of conventional induction welding include: it's only suitable for metallic liners. Quality assurance is difficult to verify as the cap covers the foil. Restricted to round designs. Heavier neck finish due to threads. Sealing can be compromised due to mismatch of tolerances between injected molded closures and blow-molded containers. BAP induction welding works mostly like conventional induction, but takes it one step further by controlling the heat distribution. This eliminates some of the limitations and disadvantages of conventional induction welding. As you can see in these thermal images, BAP technology provides perfect targeted heat distribution on the sealing area, focusing the energy only where it is required. This method delivers a perfect seal on either round or non-round shapes. Conventional induction method, by contrast, dissipates heat energy widely across the foil. Some of the advantages of BAP induction include: consumes less energy than any other welding system. It offers superior sealing performance even through dirty fill. Quality assurance through foil inspection. Suitable for both round and non-round neck finishes. Wider operating process window. ability to deliver unique features by controlling the induction process, simplifies container neck finishes with wider tolerance capabilities, and can eliminate the need for threads which may require an upgrade to an existing induction system. The disadvantages include it's only suitable for metallic liners, and it may require upgrades to an existing induction system. The complete BAP solution has three main components: an overcap, which can be attached or detached from the base, a base with a pull ring, and the aluminum foil with plastic layers on both sides. Here's a close look at what makes up the BAP foil laminate. In BAP technology, the foil laminate is welded to both the closure and container. The primary weld is the initial weld between the foil and base. This happens at Aptar's facilities. The secondary weld is between the base with the welded foil and the container. This weld occurs at the customer's facility after the container has been filled. Therefore, the BAP solution creates a permanent weld, not a peelable seal, as the other welding processes. On conduction welding and conventional induction, there is a delicate balance between the liner weld and the consumer's ability to remove it. Too much time, pressure, or heat makes the package very hard to open. Not enough time, pressure, or heat can cause sealing failures. On BAP technology, as the foil is permanently welded, the package is opened using a pull ring. This not only makes the package much easier and consistent to open, but the permanent seal is never broken. As a result, BAP technology combines a much superior sealing performance with a convenient opening system, outperforming any other solutions.